In this video, I'm going to show you a demonstration of the circuit working on the FPGA after downloading the program into the FPGA fabric. We have three components in addition to top or modules: the debounce and the square root and the PLL. That's all. And right now, I'm going to do this kind of test. We are going to calculate the square root of 9. But remember that we are dealing with fixed point numbers. So we have to scale them up by the scale parameter. In binary, this is what? This is 1001, okay? Which is 9. And then we have a total of 9 bits, and 4 of them are fraction. So we have to scale this by 4-bit, okay? And the 9th bit is a 0 here. So we input this using switches 8 to 0, as shown here. This is DN here, okay? And then give a go, okay, using switch 9, okay, positive edge on go. And then we should see on the LEDs, we should see 3, which is 1, 1, but followed by 4 zeros because of the scaling, you know. Again, we have 10 LEDs, so we expect them to be 9 LEDs for the answer and 10 LEDs in total. One is the most significant one is ready, as shown here. So ready is connected to LED R9. Okay, we expect the answer to be this. Okay, 1 for ready and then 3.0000. Okay, we'll also just for the sake of testing, we're going to test the square root of 2. We expect the answer to be very inaccurate, but let's see how inaccurate it is. In decimal, in using a calculator, so a normal calculator, the square root of 2 is going to be 1.41 something, okay? I don't need to calculate more than that because I know that my answer with a scale of only 4-bit is going to be somewhat far away from this. But let's just see what happens when we test it with just 2. And remember to put the scale bits, okay, the fraction. Right, so this is the second test case. The first test case is this. And the second test case is this. Okay, these are LDDR, expected, LDDR, expected. And these are the values of switches 8 to 0. Okay. 8 to 0. Yeah. So remember that when we prepare our input, we need to give a positive edge on switch 9 in order to latch the value of data in. So let's try this one first. Right now, this is the board programmed, ready. So the first 4 inputs, first 4 switches are going to be 0, and then 1, and then 0, 0, 1. Okay, this is actually 9. Okay, and I need to give a positive edge on go by just raising this to a 1. And as you can see here, that the answer is 3.0. The lowest 4-bit of the LED are zeros, and ready is 1. Okay, so it's 3.0. How about 2? Now 2 is basically, you need to change this to 1 0 and then followed by 4 zeros like this. Okay, and then let's give a positive edge on go in order to restart the operation, and then give another positive edge on go to latch the 2 as input. You see here the answer is 1 point in binary, 0 1 1 0. So the fractional part is 6, and 6 over 4 is somewhat, let me just punch that in the calculator. I mean 6 over 8, not 4. Sorry, 6 over 16. Yeah, 6 over 16, because this is the 2 to the 4. The scale is 2 to the 4. It's 3.75. 3.75. So let me go back to the notepad that or so the expected answer is 1.41, whereas we got 1.375. Okay, I think it's 141. Okay, so the error here is the difference between the two, which is in the order of 0.1. Okay, something like that. Okay, so this is going to be minus 9, and then so this is 3 and 0. So this is the error here. Okay, in the hopefully I got it right, but anyways, I could have punched it in the calculator. But if just the concept is correct. So we expected that the square root of 2 to become somewhat inaccurate because of the limited number of bits in the scale. Okay, that's it for the maybe later I may add some how to, for example, pipeline the divider in order to speed up the clock. Yeah, speed up the clock. I also may add something about adding an HPS and then interfacing with HPS instead of these switches and LEDs. So you can just send in a number using a C code and then get back a number using also C code, and then printing that number on the screen rather than just displaying these LEDs and trying to make sense of them. That's it. Thank you for watching, and see you soon in another video.